Hello. If there's one ratio that you know, it is the PE ratio, the stock's price divided by the stock's earnings per share. What you don't realize is that it's not the greatest ratio out there in terms of being able to compare one stock to another or a large number of stocks to each other. If you designed the ideal ratio, you would want it to be very linear and continuous in nature in terms of the distribution of stocks. This is not true for the PE ratio. Let me explain. Let's first consider Tesla. It has a price of almost $1,300, earnings per share of $4.35, giving it a PE ratio of 293.36. Now, what I want to do here is I want to think about normalizing a stock's price to $20. So we could see we could kind of divide the share price of Tesla by $63.81, giving it a price of 20. Then we'd have to do the same thing to earnings, giving it earnings per share of 68 cents. The key point here is that the price to earnings ratio does not change. Why do I want to do this? The reason I want to do this is because I want to compare stocks across the entire universe. And the easiest way to do that is to hold one of the elements constant. So we're going to normalize all the prices to 20. Now that allows us to compare just the earnings, right? So if we were to do this and kind of rank stocks from high earnings to low earnings, we would get something like this, where we're seeing the earnings are slowly declining from 20 to 19.9 to 18.8. We have a very linear distinction between these stocks. We see that the PE ratio is slowly rising. This tells us that low PE ratios are good and higher PE ratios are bad, all things equal, given that your earnings per price is maximized as the PE ratio is lower. Now, the problem is if we were now to kind of compare these PE ratios, we can think of them, we're thinking of them in a very linear way. But if we now, because earnings are declining in a very linear way, but if we graph this, we get this, which is extremely not linear. This tells us graphically there's very little distinction between these stocks at the very high end of earnings. And the distinction only becomes apparent as we get closer and closer to zero, right? So this tells us, again, it is kind of in the right direction. The low PE stocks are good and they're getting kind of slowly worse. And then all of a sudden they get really, really bad, okay? The other problem is there are in fact negative earnings. And if we then include the stocks with negative earnings, our graph now turns into this, okay? So we can see the very, very best stocks in terms of thinking about low PE being good are the stocks with negative earnings, very, very close to zero, right there in the middle of the distribution. And the worst stocks are the stocks with very, very small positive earnings, right there in the middle of the distribution. And then otherwise it's somewhat linear, but the distinctions are very, very minute. They're only in the middle of the distribution. But we've just said this should be a nice linear change, right? We should see from the left to the right, a nice, slow, steady linear increase. And that's it. But instead we have this nonlinear function and showing if we just simply go by high is good or high is bad and low is bad, then we see that the worst and the best stocks are right in the middle of the distribution, which should be the stocks that are the most uninteresting, the ones that are not at extreme. So clearly with the PE ratio, if you're trying to compare stocks, you have this distribution that's complete nonsense. Tomorrow, I'm going to tell you what you really need to do. You probably didn't know this, even though it seems kind of self-evident, but anyway, we can talk about it more tomorrow when we'll go through the alternative that is a better solution. Thanks so much.